Let's solve nth circular prime here. A quick review, a number is a circular prime if it's prime, and when you rotate the digits, say from 197, you rotate it once, and the 7 will rotate off to the left end, you get 719, which is prime. Rotate it again, and the 9 will rotate to the left end to give us 971, resolved to also prime. Rotate it one more time, you get 197, which is where we started, and we're done. Since they're all prime, they're each circular primes. Here are your first several circular primes. We're going to start out with some stuff done for us. Here's your faster is prime in a nice condensed form. Our capital A assert, in case you don't have asserts implemented as lowercase a. We have a test of n circular prime testing some of these, a main that calls that test, and n circular primes already written because after all it's just doing the standard nth pattern calling is circular prime. So the real fun is inside is circular prime, and that's where we're going to start. And we'll also start by simply saying if the number n is not prime, so if not is prime of n. If n is not prime, it certainly cannot be a circular prime. So we'll just get that out of the way. So now we know n is prime, and the question is, as we rotate n, does it stay prime? So when we get in 197, which is prime, we rotate it to get 719, and then that's got to be prime. We rotate that to get 971, and that's got to be prime. And we rotate that to get 197. And since we got what we started, we're done. And so the key is to get a rotated version of n, which would be we'll rotate n, okay? And then that will take 197 to 719. And what we want to do is keep rotating n until we've made it all the way back around to n again. So long as our rotated n has not made it back to our original n, what are we going to do? We're going to do two things. We have to make sure that the new rotated number is in fact prime. So if it's not prime, that means that we hit a rotation that's not prime, so it can't be a circular prime, return false. Otherwise, we rotated it and it is prime, so we want to keep going by rotating it again. So you just say the rotated n equals rotate of itself, rotated n. So we'll keep rotating. We'll do that until we come around to the original. If we make it back, then this will actually be false. We made it back, at which point we're done. And we can simply return true. So there you have it. Of course, we have a helper function we wrote, or which we used, rotate. So for rotate, we need public static int rotate int n. And it's going to take an int and give you back a rotation. In order to make sure that we have this right, we're going to want to use a test method for it. And so here's one that we just coincidentally have available to us. Maybe I anticipated we might need it. And we'll go down into our main. We'll make sure that we test our rotate method before we test our nth circular. Okay, to continue, how are we going to rotate a number? So for starters, we don't need it to be general. We know that the number that's going to come in is being positive. We'll just ignore the other case. Now, if we have, say, 197, we're going to want to rotate that to be 719. So basically, we're going to pull off the ones digit, and everything that's left is going to remain intact, right? So like if we had 1, 2, 3, 4, 5, 6, 7, that would go to 7, 1, 2, 3, 4, 5, 6. So once you pull off the ones digit, everything else stays as it is. But then you want to multiply that ones digit by the power of 10 you need to shift it beyond the end of this number. That's easy enough. Keep making a power of 10 larger until it's larger than that number. Just multiply the ones digit by that, and that'll shift it over. In other words, this equals 7 times 100 plus 19. And this equals 7 times, let's see, 10, 100, 1,000, 10,000, 100,000, a million, right? So 7 times 1, 1, 2, 3, 1, 2, 3, plus 1, 2, 3, 4, 5, 6. So if you notice, it's ones digit times power of 10 plus everything but the ones digit. Fine. So to begin with, we'll say our ones digit is simply n mod 10, and our result starts out as n over 10 initially. So that's going to be our result without the ones digit, which we have to shift now to the left. And finally, our shifter is going to be simply, or the power of 10, that has to be bigger than our result, right? Think about it here. Our result for 197 at this point is 19. We have to get our shifter to be 100. The first power of 10 larger than 19. So initially we'll just do 1, and now simply while our shifter is less than or equal to our result, we'll multiply our shifter times 10. Now that made our shifter equal to 100 in this case and to 1,000,000 in this case. And finally, our result plus equals our old ones digit, but now multiply our shifter to shift the ones digit all the way to the other end of the number. Now we just go ahead and return the result. And let's see if this works. We'll compile this, and we'll run it. And it did not work. Let's see why. Our test rotate said division by 0 on line 45. So right here we had a division by 0 on line 25. See how it says? Wait, I'm sorry. On line 45, test rotate, division by 0. Oh, wait, I'm sorry. The division by 0 simply in our assert. Stay with the program here. But this failed us. And the reason it failed us is actually our test cases are broken. I'm sorry. This is rotating in the opposite direction as we did. What we rotated was we plucked off the ones digit and put on the other end. So in fact here we would pluck off the ones digit and put on the other end. We didn't have a broken rotate, we had a broken test rotate. So let's go ahead and compile again and run this. And we passed our fixed test rotate, and while we're at it, it turns out we also passed our nth circular prime. So there you have it. I will also post this code to Piazza, so you'll have the code and the video to explain it. There you go. Hope this helped.